Hey guys, welcome back. Today we're not really going to do anything new, but how you interpret the question it's a little tricky. So here we go. Before I get started, I would like you to legit do this on your own. Answer all four of these questions. Literally, f of 2 means plug in a 2 for x up here. So I think you can see what that's going to equal right away. F of 3, you'd plug in a 3. Then you're going to have to integrate and plug in the 3 and the 2 and subtract. Okay, so do that for all four of these. Hit pause. Okay, so here's my work where I integrated all of them. So F of 2 means you're integrating from 2 to 2 of who cares, that's 0. F of 3 means you're integrating from 2 to 3. And you plug in the 3 and the 2 after you integrate, and you should have gotten 5. Okay, f of 5 is really an integral from 2 to 5, and f of 0 is the integral from 2 to 0. And that's where the smaller number actually went first. We got a negative answer there. All right, so now let's look at what these things are graphically. I'm going to rewrite what all of it equaled now that you can see how we got it. And we're going to look at how it would be interpreted graphically. Okay, so what does this integral represent? It's the area under the curve of this equation, which is the line y equals 2t. So that would be the equation. And it has a y-intercept of 0 and a slope of 2. So if this is 0 and it's up 2 over 1, up 2 over 1. Okay, so that's the equation. That's that. I just graphed y equals 2x. That's all I graphed. Well, the integral would then be the area from 2 to whatever that number is. So the first one was from 2 to 2, so I'm starting here at 2, and I'm going nowhere, and that's why that answer is 0. Well, this one is the area from 2 to 3. So I'm starting here, going from 2 to 3, and if you found that area, counted up all the squares with graph paper, that has a positive area of 5. Okay, keep going, work with me here. At 5, that's the integral from 2 to 5 up here. Okay, so this would be a 5. So we're still starting at 2. We're going over to 3, 4, 5. It would be all of this area. Okay, so that would be that. And that's why that's 21 if we counted up all these squares. But how do we do this? Okay, let me erase all of that. Okay, how do we do the integral from 2 to 0? We were starting at 2 and now we're going backwards. That's why the answer ended up being negative. Well, here's how you want to work that. If you were doing this graphically, when I have to find area graphically, I didn't have to reverse these bounds to just get that -4 algebraically. But if I want to get the -4 graphically, I would reverse the bounds and start at 0 and go to 2 and put a negative out front. So what I want you to get from this is you don't need to reverse the bounds right here when you're just doing math. But if you're trying to calculate that math on a graph, then you want to always calculate your area from least to greatest. So if you have to reverse these bounds if you're calculating an integral on a graph. So it's the area from 0 to 2, which is going to be a positive number with a negative out front, -4. Okay? So what we're looking at today is the accumulation of area. Okay, and that's why they call these accumulation functions. Now, it is possible to graph this entire equation and look at that graph, but it's just as possible for us to figure out what that equation would be by integrating and plugging in the x and the 2. But I think the common sense understanding of its accumulating area is the part I really want you to get out of this. So, having said that, let's look at a sample problem, okay? Remember, you're accumulating area, and you're starting at this number right here, okay? So read part A and give it your best guess for right now without me. Hit pause. Okay, so let's see what you said. We're starting at -3, so we're starting here, and we're accumulating area up to -1, because A of -1, that means x is -1, and that means we're going from -3 to -1. Okay, so that's area from -3 to -1. So we're comparing this area, okay, whatever that is, to A of 1 would be plugging in a 1 right here. So that's -3 to 1, that area. Well, that would be from -3 still all the way over to 1. So the one with the bigger area is obviously the larger value, so it's A of 1, the blue one, okay? So when is this thing going to start to get smaller? Well, we're going to be accumulating positive area, positive area, positive area, positive area, positive area. Once we get here, now this area starts to take away from the total. This is negative, okay? That brings me to option B. Hit pause and try that one now. Let me erase all this for you, though. Okay, try part B. Okay, so hopefully you can see that, you're always going to start at this number. So we're still starting at -3 and then going up to 2. So we're comparing -3 to 2 to -3 to 4. Okay, that's what we're comparing right now. So starting at -3, if we go all the way to 2, all of this is positive, positive. We're adding area, adding area, adding area, accumulating area. And now when we get here, we start to subtract from the area. So this little bit of red balances out this amount of blue. My total answer would be whatever this is left over. Okay, that's this one without getting an actual number. Then A of 4 would mean we keep going more into the negative, more negative, more negative, more negative. So now we're going to take away all of this red area from the blue area, which means this one is smaller. It's taking away more area. So the answer to this one, which one is larger, is A of 2. Hopefully you got that. Now look at C. There's a very common sense understanding. If you get that the integral is an accumulation of area starting at -3, then you can see where the area is getting bigger and then where we start to subtract from that area. And you can do this pretty common sense. So write down your answer. Let me erase all this. Okay, hit pause. So A will be increasing if the area is accumulating positive area. So this would be increasing everywhere from here to here to here. We're still getting more area, more area. So A is increasing. It's still increasing. Here's where you might have had a question. This is definitely still increasing, but is this not still adding area? So this is still adding area. This is still increasing, even though that goes downhill. The area, the total positive area is increasing, total positive area increasing, and it's not till you get to here that we start to deduct area. So A is increasing from -3 up to 1, okay? So from -3 to 1, okay? After that, this below the graph starts to take away area. Hopefully that makes this part also logical. There's a logical answer, okay, that this is a maximum right here. And it's because the areas are accumulating positively and this starts to take away from it. But let's say you got to look at that another way, or maybe you're one of those like me. I was always like this. Common sense was really not my thing. I needed facts and I needed to always know, do the same thing, do the same thing. So here's how you could do this question using your formal justifications. Max of A of X would be A prime equals 0 and changes positive to negative. Okay, so now I would find A prime. Okay, and that means finding the derivative of this. Well, that's the lesson we did. What was that, just yesterday? So A prime will be fundamental theorem of calculus, derivative of an integral. You just replace the t with the x. So A prime is just f of x. Now we're going to look for when that equals 0. Well, this is f of x, and it equals 0 right here, and it changes from above to below right there. Okay, so there's more than one way to justify it. You have the common sense accumulating area, and you have your formal definition. Both will work to help you understand that. Okay, so why don't you guys try the next one? Okay, so on this one, you're going to need your formal definitions. I want you to recognize that this is an f prime graph. This is really not new information. It's just a chance for me to do one that's similar to an AP question. Now, pay attention to this. If it says something is a quarter circle, and they say that a lot on the AP exam, okay, then that means that this area has an exact answer because it's a fourth of a circle. So it's pi r squared, area of a circle is pi r squared. But then, and r would be, you know, r is 2, okay? And then this is a fourth of that total circle. So if you need this area, you're going to actually use the formula for the area of a circle. So I'd like you to use your formal justifications, everything you've learned, and see if you can do this problem on your own. It is a little tricky, but you can do it. I'm going to clear everything. Okay, hit pause and actually try to do this on your own, and then I'll work it out for you. Okay, I haven't worked them all out yet, but hopefully you figured out to figure out Roman numeral 1, whether or not that's true. This is an old lesson from last week. To find f of 6, that's an antiderivative, because this is a derivative graph. To find an antiderivative, I need another antiderivative. So this is how you start this one. Then f of 2 is 3. This I'm going to have to calculate area from 2 to 6. Hit pause again if you didn't already do all of that correctly. Do it again. So now we're doing the integral from 2 to 6. So you had to find the area of the quarter of a circle, 1/4 pi r squared. So that's 1/2 of pi times 4. And a fourth of that would just be pi. And then the area from here to here is the area of a triangle, 1/2 of 2 times 4, which is 4. So this integral is pi plus 4. Parentheses weren't really necessary, so it's just pi plus 7 or 7 plus pi. So this is not true. That is false. All right, so now do the same thing. Take each one slowly, piece by piece. Hit pause and do part 2. Okay, minimum. That would be derivative of f is 0 or undefined and changes from negative to positive. This is a derivative. Okay, think about that. What do you say? So the derivative is 0 here and here, since this is a derivative. Okay? Now, it changes from negative to positive, though, at just one spot, and that would be here. So this is true. Okay? Now the last part, Roman numeral 3. Hit pause again. Okay, part 3. Inflection point, that means second derivative changes signs, which implies it's 0 in between, but it has to change signs. You've got to write that if this was an AP question that was free response. All right, so we need the second derivative, all right, at 0 and 4. All right, well, if this is a first derivative graph, then the second derivative would be the slope at 0 and the slope at 4. Okay, so the slope at 0 is not 0, it's positive. So that's not true. And at 4, that's undefined, but it does change signs. This one would be an inflection point. So basically, that's false because of this one. So go back, what do we say was true? I think Roman numeral 2 was the only one that was true. All right, so that was kind of a review of everything. Here's your assignment for today. I don't think we had time for that one. All right, good luck, guys. Bye.